Assemble.
Hello dear students, today we are going to start with a new chapter, and the name of the chapter is Coordinate Geometry in Two-Dimensional Plane. So we are going to study about coordinates on a Cartesian plane. Cartesian plane is a two-dimensional plane. There are three sections in the chapter, the first of which is distance formula, the distance between any 2 points that is there on a Cartesian plane. Secondly, we are going to study about section formula, the point which divides the join of any 2 points on a Cartesian plane. And the third thing that we are going to do in this chapter is the area of a triangle. So we'll start with distance formula. So for today's class, the following are our learning objectives. Firstly, we'll recapitulate some key ideas and concepts of coordinate geometry. The second thing that we are going to do is relate distance formula with Pythagoras theorem, the theorem which relates the three sides of a right triangle. And finally, we are going to apply distance formula to find the length or the distance of a line. So it is believed that it all started with a fly and a man named René Descartes. Descartes is believed to be one of the finest mathematicians of 17th century and is often credited with a lot of contributions in the field of mathematics, out of which coordinate geometry is certainly one of his finest. The picture here is an illustration of how Descartes actually came about the discovery of the two-axis coordinate system, which are also used for graphing. So the story goes that he lay in bed and watched flies crawling over the tiles on his ceiling. He realized that he could describe a fly's position using the intersecting lines of the tiles, and this system therefore is often called the Cartesian coordinate system in his honor. Now, some of you might be wondering, why didn't someone give Descartes some of these? On to the serious matter again. It is also believed that the first person to actually describe the coordinate system was Pierre de Fermat. Fermat had a book of math investigations written around 1629, but due to some reason was not able to publish it until about 1679. Descartes, with his modern version of XY ordered pair of coordinates, which are now known as Cartesian coordinate system, was able to introduce his idea to the world in 1637, although he had written his idea 8 years later than Fermat, but was able to produce it to the world or introduce it to the world much faster than Fermat. That is why the modern coordinate system has been credited with Descartes, and that's why it is known as Cartesian coordinate system. Now, ordered pair in Descartes' system means the x coordinate always comes as the first coordinate and the y coordinate comes as the second coordinate, and they are separated by a comma inside a round bracket. So x coordinate is the first coordinate and y coordinate is the second coordinate always. So right here, this is a Cartesian plane or a xy plane, which is made up of two perpendicular number lines, as both the lines bear numbers. The horizontal line is called the x-axis or the abscissa, and the vertical line is called the y-axis or the ordinate. The two axes intersect at a point known as the origin, and the coordinate of the origin will be 0, 0. The two axes divides the plane into 4 areas or the 4 parts, and they are known as quadrants. The top right quadrant is the first quadrant, and the direction of the quadrant goes in anti-clockwise direction like this. The positive direction is upwards for the y-axis and towards the right for the x-axis. So the first quadrant will be plus x and plus y, as x-axis is towards the right and y-axis is upward. The second quadrant will be minus x plus y, as the x-axis is towards the left and y-axis is upwards. The third quadrant will be negative x, negative y, as x-axis is towards the left and the y-axis is downwards. The fourth quadrant will be plus x minus y, as the x-axis is towards the right but the y-axis is downwards. Let us start with the first topic of the chapter, and that is distance formula. So for that, let us take any two coordinates. So we are taking 5, 2 and 2, minus 2. Remember, whenever we are denoting the name of a coordinate, we should always use the uppercase of the English alphabets. So that's why capital P and capital Q, always capital letters. And obviously the coordinates always has to be written inside round brackets, with x coordinate coming first, followed by y coordinate and separated by a comma. And this should never be equals to sign in between the name of the coordinate and the value of the coordinate. So let us join the two coordinates. Here we have got a line PQ now. So we need to now find the distance of this line PQ, the length of line PQ. So for that, let us draw perpendicular lines from P and Q like this and intersect it at R. Now, if you can see, this has actually formed a virtual right triangle, as the line from P as well as from Q, they were perpendicular. That means they have formed a virtual right triangle. Let us first find the length of the line segments PR and QR. First, PR. As you can see, PR is parallel to x-axis and the change is only in the x coordinate. The y coordinate is same, minus 2, it's same in P and R. The x coordinate is changing. The x coordinate was 2 at P and it has become now 5 at R. Similarly, QR is parallel to y-axis. That means the change is only in y coordinate. As you can see, in Q and as well as in R, the x coordinate is same, 5 and 5. Whereas the y coordinate has changed. It was 2 in Q, now it has become minus 2 in R. So change in x-axis, that is PR, equals to 5 minus 2, new coordinate 5 minus the old coordinate 2 equals to 3 units. And change in y-axis, QR, equals to, the initial point was at 2 and the end we have ended up at minus 2, 2 minus minus 2. So PR equals to 3 units and QR equals to 4 units. Now since this is a right triangle, PQR is a right triangle, we can use Pythagoras theorem, which says hypotenuse square equals to perpendicular square plus base square. So now PQ square, which is hypotenuse, equals to PR square plus QR square equals to, the magnitude of PR is 3, so 3 square plus QR is 4, so 4 square. So we have got PQ square equals to 9 plus 16 equals to 25. Taking the square to the other side, we'll get PQ equals to square root of 25 equals to 5 units. So we have calculated the length of PQ using the Pythagoras theorem. So do we have to do this all the time to find the distances? No. We can formulate a very simple formula from this. This was done in order to relate the distance formula with Pythagoras theorem and also to understand how we can derive distance formula. So I hope this is done till here. Now let us see how can we derive distance formula. We had used this formula to calculate the distance of PQ, and PQ was under root PR square plus QR square. So now in order to derive distance formula, let us inspect the nature of PR and QR. Remember, PR was simply the change in x-axis, y coordinate was not changing, and that's why PR was 5 minus 2. Now see, 5 minus 2 is actually x coordinate of Q minus x coordinate of P. And similarly, QR was changing only y-axis. X coordinate was not changing, and it was QR equals to 2 minus minus 2. So that 2 minus minus 2 is simply y coordinate of Q minus y coordinate of P whole square. Hence, our distance formula can be PQ equals to under root x2 minus x1 whole square, x coordinate of Q minus x coordinate of P whole square plus y2 minus y1 whole square, that is y coordinate of q minus y coordinate of p whole square. This is our distance formula. Now what if we had taken it the other way around, that is instead of pq we had taken qp? The distance would not have changed because the points are same, so irrespective of which way you are moving, the distance will still be the same. The only difference is now p is the second coordinate and q is the first. So the coordinates of p will now subtract the coordinates of q. So qp will be equals to under root x1 minus x2 whole square plus y1 minus y2 whole square. So now in order to understand the distance formula even better, let us do some questions. The first one is find the distance between the points 2, 3 and 4, 1. The name of the points are not given, so we can denote them by any letter. So we have used P and Q. P 2, 3 and Q 4, 1. Now, since we are in the initial stage of doing the questions, let us denote all the coordinates like this. Once you are confident, you can skip this step. x1 equals to 2, y1 equals to 3, the coordinates of P. 2 is x1 and 3 is y1. And x2 equals to 4, y2 equals to 1, the coordinates of Q. x2 4, y2 1. Now the distance formula is pq equals to under root x2 minus x1 whole square plus y2 minus y1 whole square. Now simply put the values. x2 is 4, x1 is 2. So 4 minus 2 whole square. y2 is 1, y1 is 3. So 1 minus 3 whole square. So we will get 4 minus 2, 2 square plus 1 minus 3. 3 is the bigger number having a negative sign. So negative sign will retain. 3 minus 1 is 2. So minus 2 whole square. 2 2s is 4. Minus into minus plus 2 2s again 4. So we are getting 4 plus 4 under root 8. So under root 8 we can express as 2 into 2 into 2. 2 2s are 4, 4 2s are 8, prime factorization. Since we have one pair of 2, so PQ will be equals to the one pair of 2 which is under square root, that will come out. So 2 and 2 will still remain inside the square root, that is PQ will be 2 root 2 units. So we have calculated the length of PQ. Let us move to the next question now. Find the distance between the points minus 5, 7 and minus 1, 3. Just for a change, let us take the two coordinates as A and B. As I've already told you, since we are in the initial stage, let's write each of the coordinates separately. So x1 equals to minus 5, y1 equals to 7, they are from A, x2 equals to minus 1 and y2 equals to 3 from B. So now AB will be equals to distance formula x2 minus x1 whole square plus y2 minus y1 whole square. Second coordinate minus first coordinate, B minus A. So see, minus 1 minus minus 5 whole square plus 3 minus 7 whole square. Next step, minus 1, now minus into minus plus. So the sign has changed, minus into minus plus 5 whole square plus 3 minus 7, that is 7 is the bigger number, so 7 minus 3 is 4 and 7 is the bigger number, so minus sign will carry on, minus 4 whole square. Now 5 minus 1 will give us plus 4 square because 5 is the bigger number and it has plus sign. So 4 square plus minus 4 whole square. 4 4s are 16, minus into minus, since square that means minus sign will remove, 4 into 4 will give us 16. So 116 plus 116 we can simply write 2 into 16 since both are same. Instead of writing root over 32 we can also write 2 into 16. 116 plus 116, 216, so 2 into 16. Now we can express them as 2 into 4 into 4. So 4 is in pair inside square root, so 4 we can take out. So AB will be 4 under root 2 units. On to the next question. The next question is find the distance between the points P, A, B and Q minus A, minus B. The question is slightly different. This time around we don't have numbers, we have variables, the coordinates of P and Q. So now x1 is equals to A, y1 equals to B from P, x2 equals to minus A and y2 equals to minus B from Q. The formula is still the same, root over x2 minus x1 whole square plus y2 minus y1 whole square. Now let us put the values. x2 is minus a minus x1 is a. So minus a whole square plus y2 is minus b and y1 is b. So minus b whole square. Minus minus plus, but sign will remain minus. 1a plus 1a will give us 2a. So minus 2a whole square. Similarly, minus 1b plus minus 1b, that is minus 2b whole square. So minus into minus plus, 2 2s are 4a square. Minus into minus again plus, 2 2s are 4b square. Now in both the things 4 is common, so we can take 4 common out. So inside the bracket we'll get a square plus b square. Now the 4 that we have outside, we can express that as 2 into 2. 2 2s are 4. And a square plus b square, since they are variables, we cannot express them as product. Now since this 2 is in pair, we can take this 2 out. So PQ will be 2 under root a square plus b square units. So we have got the length of PQ. Now one more question. The question is, find the distance between the point 8, minus 15 and the origin. So the 2 points are, the first point is given 8, minus 15 and the second point is origin. So origin means 0, 0. So you need to remember that origin's coordinate is 0, 0. Now our coordinates are x1 and y1, they both are 0 as they are coordinates of origin. x2 is equals to 8 and y2 equals to minus 15 from P. So PO, since the distance is from P to O, 8 minus 0 whole square plus minus 15 minus 0 whole square, as x1 and y1 they both are 0. So we'll get 8 square plus minus 15 whole square. So 8 8s is 64, minus into minus plus 15 15s is 225. So if we'll add up, we'll get root over 289. Root over 289 is 17 into 17, as 17 is in a pair. So we'll get PO equals to 17 units. So we have calculated the distance between the point 8, minus 15 and the origin as 17 units. So this is also done. Now these are the questions which are for your assignments. The questions are similar to the ones which we have discussed in the video. So you can refer to the questions which we have discussed in the video and try to solve these questions. And while doing your assignments, don't forget to thank them. Have a nice day.